So these notes are on graphing sine, cosine, and tangent functions. So the first one we're going to look at, and is often the one used as sort of the anchoring one, is sine. So y equals sine x. And the first thing we're going to do is we're going to look at a table of values and kind of see some patterns. So I am going to break this up. It's quite a long table, and in part it's a long table because we're actually going to look at the 4 quadrants. So I'm going to go 0, 30, 45, 60, 90, and for 90 I'm going to write that as root 2 over root 2 also. Then I'm going to go 120, 135, 150, 180, which I'm also going to write in radians, pi, 210, 225, 240, 270, which is also 3 pi over 2, 300, 315, 330, and 360, which is also 2 pi. Now, kind of going back to my unit circle, I can go through and I can fill this in relatively quickly. I know that sine is my x coordinate. Sorry, I'm writing it and I'm forgetting that sine is my y coordinate. So at 0, I'm at the point 1, 0. And then I just can fill in the 90-degree ones. For the 45, I am at root 2 over 2. Sine is positive in the second quadrant, but it is negative in the third and the fourth. And if I get an estimated value here, this is approximately 0.7, approximately 0.7, approximately negative 0.7, and approximately negative 0.7. For my 30, 60, 90, for the 30, my angles are always, my y-coordinate is always the 1/2. So that's going to be the 30, the 50, the 210, but of course it's negative because it's the third quadrant, and the 330, but again it's negative because it's the fourth quadrant. And then for my 60s, my y-coordinate is always root 3 over 2. Positive in both the first and the second quadrants, negative in both the third and the fourth quadrants. And these values are approximately 0.87. Whoops, here we go, negative 0.87 and negative 0.87. And so now I'm going to graph this. And generally speaking, when we graph sine, cosine, and tangent functions, we actually graph them using our radian measures. So I am going to use graph paper, as we've always done. I'm just going to scale my graph differently. So in this table, I can see that the largest number I have is +1, and the smallest is -1. And then I'm going to scale. I'm actually going to kind of ignore the 30, 45, 60 for right this second. And I'm going to anchor us at 0 degrees, pi over 2, pi, 3 pi over 2, and 2 pi. And I'll do that for the negatives also. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So at 0, I'm at 0. Between 0 and 90, I am going up, 0.5, 0.7, 0.87. Whoops, I said I was at 0, 0, and then I graphed it at 1. So 0, 0. And from 0 degrees to pi over 2, I'm going up. So I'm going up, 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 and I max out at 1. And then I start going down, 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 and I end up at 0. And then I keep going down, but I go down into the negative until I reach -1. And then I start going back up again until I reach 0. And so my sine function has this shape. And it's it's the same pattern on the other side, so that I would go down to -1, up to 0, up to 1, back down to 0, and there is my function. Oh, whoops. I did not count my boxes right here. I apologize. There we go. Now that looks better. And depending on your teacher, they may want you to do 2 cycles, 1 cycle. And a cycle really is from bottom to top to middle, from middle to top, middle to bottom. And that gives you a nice sort of general shape for the function. Now, once we've done the sine function, it actually turns out that seeing this pattern allows us to do the cosine function pretty easily. And so what I'm going to do is I'm going to just cover this up. And so for y equals cosine x, we saw that really the most important numbers in our table for the sine function were our anchor points of 0, pi over 2, pi, 3 pi over 2, and 2 pi. So that's the anchor points I'm going to use for the cosine. So I have 0, pi over 2, pi, 3 pi over 2, and 2 pi. And in this case, we'll remember that cosine of theta is our x-coordinate. And so I'm looking at the point 1, 0, 0, 1, -1, 0, 0, -1, and then back to 1, 0. And so I'm going to scale my axes in the same sort of way. So I can really see this. I know that very often we do 1 box as 1 unit, but it's kind of nice with the cosine and the sine to have it be a little bit more stretched out because it allows me to see the general shape just a little bit better. I should label this x and y. That would be good to label it the correct x and y. Okay, so unlike the sine function where at 0 we were at 0, for the cosine function we're actually at 1. We go down to 0, down to -1, back up to 0, back up to 1. And so our sort of parent function, mother function for cosine, has that shape, where in our parent function for sine, we had this shape. Turns out the general shape is exactly the same. It's just a matter of the perspective of where you're looking. It's a shift one way or the other. So I can also fill in this side of my graph. Whoops. There we go. So that I have 2 cycles done.